Hello again, fourth graders, and welcome back to Math Workshop. Today we're going to talk about another strategy for multiplication that not many people use, to be honest with you, but over the years of teaching it, I have found that some people, some kiddos, just really love this method and they end up having this be their go-to method. So remember, our job is to teach you as many different strategies as possible for how to multiply numbers. And so today we're just going to learn one more strategy. So remember, we've already learned a couple of other ones. We've learned how to partition rectangles, right? Breaking numbers into their place value parts and multiplying smaller factors together to find the product in the end. We also have learned partial product, where we also use our place value knowledge and do those smaller products off to the side and then add them up. And so today we're going to learn yet another strategy for multiplying big numbers, and this one is called lattice. This is called the lattice method. So, like I said, not many people usually go to this one, but just in case you ever see a question on iReady or MSTEP that asks you to try using this method, or maybe they give you one and they want you to check it to make sure that somebody did it correctly, you'll know how to do it. Okay. So when we do lattice, what we're really doing is kind of drawing a fancy picture, still using our knowledge of breaking those digits up into their place value parts. So let's try this one simple first, and then we'll get a little bit bigger and a little bit bigger so that you can really see how to build that lattice as you go. So it's a little bit similar to partitioning rectangles, but when we partition our rectangles this time, we're not going to use just the traditional making squares or rectangles. This time we're going to use a diagonal line, lattice. So our problem today that we're going to focus on is 3 times 64. Okay, so just like we did when we partition our rectangles, I've drawn myself a rectangle. Okay, but look at how I split my rectangle up. Look how I did that. So just like when we partition rectangles, I put the small factor on the small side of the rectangle. And on the big side of the rectangle, I wrote each digit of the next factor. It's a little bit different from when we did partitioning rectangles, because when we partitioned rectangles, we would have left this to say 60. But this time we're going to leave it just as 6. It's still in the tens place, but we're going to leave it just as a digit itself. So it's a little bit different from partitioning rectangles, okay? So just like with any problem, there are some steps to follow, okay? So the first step that you want to follow is to write the factors on the top and the bottom, which we have done. 3 times 64. Okay, then we draw those lines. So we're going to create diagonal lines in between each section of our rectangle. We're going to break our rectangle into smaller parts, and we're going to draw those angles on a diagonal. So it creates a lattice effect, like you would hang in your garden. Okay. So step number 2 is then to multiply across these digits, and then we're going to put them together to find the final product. Okay. So the next thing we have to do is we have to multiply the single digits on the top and on the bottom to fill in these diagonal squares. So here we go. The way we do that is by doing this. We multiply 3 times 6. And when we know what our product is, 18, you can see that we've broken that rectangle into 2 spots. That's for place value. So I'm going to write 18 like this. I'm going to break that number into its place value parts. The tens place goes in the first diagonal, and the ones place goes in the second diagonal. Then we work our way through the problem. 3 times 4 this time. 3 times 4 is 12. So the same thing we did, we're going to break that number 12 into its place value parts. 1 and 2 down in the bottom. Okay. Step number 3 says that we have to add diagonally. So what that means is what we're going to do is we're going to create ourselves a little addition problem based on the diagonals. So in this case, we have just the digit 1. We're going to not add that to anything else. We're just going to leave it 1. So it's imaginary 1 plus 0. 1 plus 0 is 1. And I'm going to write the answer off to the side. Now we're going to do the next row Okay, we're going to do the next row right here. 8 plus 1 is 9. So I'm going to write the 9 down there. And remember, do you notice that I kind of made my lattice extend quite far down so that I have lots of room to write my answers. Okay, the next one is 2. And since it's all by itself, it's kind of like saying 2 plus 0. So I'm going to put the 2 right down there. The next step tells me to put the product together. So what we're going to do is we're going to look all the way across the left-hand side, all the way across the bottom, and we're just going to put these numbers in order like this. 1, 9, 2. So the product of 64 times 3 equals 192. But just to make sure, we always double check. And since I'm really, really good at the partitioning rectangles and I've practiced it lots and lots, I'm going to use that to double check my work. So this time I'm going to do it just like we did last time. I'm going to do it 3, small number on the small side, big number on the big side, and I'm going to break it up like I know, 60 and 4. So 3 times 60 equals 3 times 6 is 18 plus 1, 0. 3 times 4 is 12. And we know that we have to then add 180 plus 12. 8 plus 1 is 9. 1 plus 0 is 1. So 192 checks out. So I know that my answer up here in my lattice is correct. Kind of strange, right? But a lot of people really, really like it. Let's try one more example. And then I'm actually going to show you a picture of a third example before you go off on your own to try it. That way you can see that no matter how big the problem gets, no matter how many digits there are in your factors, you can do this work. Okay, here's another example. Let's do this one together. Okay. 713 times 5. 713 times 5. So the first step, of course, is to write the factors, the numbers of the factors on the top and the bottom. So I put the small factor 5 off to the side, and I'm putting it off to the right-hand side so that when I do my addition, I can just leave this side blank, right? So it doesn't matter if you do it on the left or the right, but it's easier for me to put the small factor on the right-hand side so that when I'm doing my addition, I've got all the space over here to add whatever is in this section. I don't want to get myself confused. So then I'm going to take my big number, the big factor, 713, and this time I'm just going to put place value spots. I'm not going to write 700 like I would if I were partitioning rectangles. I'm just going to write each individual digit, 713. Now, since there is only one digit in this factor over here, I only need one diagonal in this lattice. I don't need to do more than one. I can only just do one diagonal. Okay, step number 3 is then to multiply my way through here. So I'm going to do 5 times 7. 5 times 7 is 35. So remember, the 3 goes in the top section of my diagonal, and the 5 goes in the bottom. 5 times 1 is 5. So I could leave this blank, but just so that I can make sure that I'm filling in all my blanks and I don't leave anything to chance, I'm going to write 0 in the tens place and I'm going to write 5 in the ones place, just so that I can make sure that I'm keeping track. 5 times 3 is 15, so I'm going to break that number 15 into its tens place and its ones place. Now I need to do my addition, right? So 3 plus 0 is 3. 5 plus 0 is 5. 5 plus 1 is 6. And 5 plus 0 is 5. So now that I've got all of my addition done, I'm going to just go around, ring around the rosy kind of thing here, and I'm going to put my numbers in order. 3,565. Now, just to make sure that I've got everything in order, I'm going to double check using a strategy that I have practiced with a little bit more and that I know really, really well. So I did my partitioning rectangles. It's a little bit different, but I know it really well. So I'm going to do my base problem. 5 times 7 is 35, and there are 2 zeros. 5 times 1 is 5, and there's 1 0. 5 times 3 is 15. So if I do my addition, like I always do, 5, and that's 5. 5 plus 1 is 6. 5 plus 0 is 5, and 3 plus 0. 3, 5, 6, 5. We're good to go. So I know for a fact that my lattice multiplication is correct. Now, I'm not going to do this one with you, but I do want to just show you that it is possible for you to do this with big, giant multi-digit numbers as well, okay? So the way that you do that is it's the exact same as you would use for 1-digit numbers, but see how in this one I just wanted to show you how you would create a lattice with multiple digits. So just like always, the small number I put on the small side, and of course I put it on the right hand side so that I've got all this room over here to do my addition when it's time. And see what I did? What I did instead of just doing one lattice, it's similar to how I partition rectangles. So I put the 2 and the 6, I broke that number 26 into its 10 and its 1 place. And I drew a line right down the middle to show my 10th place and my 1's place. And then I, of course, put my big factor 264 on top. So then, just like always, I draw my diagonal lines for my lattice, but you'll see that it creates an even bigger, more complex lattice because I've drawn this line in the middle to separate these 2 digits. So if this number were 267, I could even do the same thing. I could write 7 down here and continue my lattice down. It doesn't matter. So even though the numbers get really, really bigger and multi-digit, you can still do lattice the same way. Okay, so you would still attack it the same way. You would do the tens place first. 2 times 2 is 4. 2 times 6 is 12. 2 times 4 is 8. And then you would do the same thing for the 6. 6 times 2 is 12. 6 times 6 is 36. 6 times 4 is 24. And then when you're done, you still do the addition and then you still put the product together. You just have lots more numbers to work with. 3, 4, 5, 6, 7, 6, let's see, 8, 10, 16, which this can't stay. Look at this one. So the number 16, we can't leave it like that. We have to leave the 1's place alone and take this one and carry it over here. So now this number turns into 8. And the 1 disappears, right? Just like we would if we were borrowing and carrying an addition. And 4 plus 0 is 4. So now the numbers that I'm going to have are 6, 8, 6, 4. And if I do my double checking with my partitioning rectangles, I get the same exact answer, 6,864. So even with big giant numbers with multiple digits in your factors, you can still use lattice. It's just that you have to draw those lines down the middle to show place value parts. So give this one a try today and let me know what you think. I've been happily surprised in the past. Some kiddos really, really like this method and they find it much easier than even partitioning rectangles. But remember that the key is to use a different strategy that you know even better to check your work just to make sure that you're on the right track. So off you go, giving this lattice method a try and let me know how it goes. Off you go, fourth graders.